red hot. We'll never get across. Hacker's gonna win.
No way. That is not gonna happen.
Hey, what's this? Tile?
Let me see. Whoa! What? Sorry.
Look, it floats, and it shields the heat.
Maybe we can make a path across the lava with tiles, just like we made a raft to get across the river.
But these tiles are so small. We'll need lots and lots to make a path wide enough to walk on.
And they have to fit tight. No gaps or our toes will be toast.
No problem. Let's tessellate them.
Problem? None of these are squares. Only squares give us no gaps or overlaps, right?
We don't know that for sure, Didge. Maybe we can do it with triangles.
How? These have 3 sides, not 4.
Wait! At least the sides are all the same length, like the squares.
And every triangle is the same size, too.
That helped with the squares. Let's try them. Nope. Oh, not working. Gaps everywhere.
What if we slide this top row over a bit, so the corners meet, like the squares did?
Hey! The gaps look just like our triangles, only upside down.
So, flip the triangles.
The triangles fit together exactly. No gaps, no overlaps. It worked.
Let's see what happens if we add more triangles here. A tessellation. As long as we use the same pattern of triangles, we can make the pattern as big as we want. Start tessellating.
Way to go, guys! We're halfway across.
Only one thing! We don't have enough triangles to finish the path!
Just when things were going good.
Wait, what about those other tiles?
These tiles don't work. Game over.
You sure? That's what we said about the triangles.
Okay, what do we have here? A pentagon. 5 sides, all the same length. Equal angles, just like the squares and triangles. But here's the difference. 5 pentagons together leave a big gap, and there's no way to add one to fill that gap without an overlap.
And the lava could ooze through that overlap.
What we have here is a failure to tessellate.
All right, pentagons are out. Next. Out, out, out.
How about these hexagons? 6 straight sides, equal length, equal angles. All the same size. 2 together leave a big gap, but a third one fills it exactly. A perfect fit.
And look! Every time we add a hexagon, we have more gaps that other hexagons can fill. So we can make this tessellation as big as we want it.
Game on, guys! Let's finish this bridge over troubled lava.
Just slide these hexagons into those empty spaces, like so, and the big T is done. Yes! No gaps, no overlaps. Tessellation complete.
Good job!
Woohoo! Way to go, Didge!
Let's sack the hat.
Gee, there are a lot of choices.
Hi, how can I help you today?
I would like to wallpaper my living room. Here are the dimensions.
I estimate you would need about 20 rolls of paper. Can I see the paper you like? You totaled $600.
No way. I'm afraid I can't afford that. Sorry for troubling you. Are you throwing those out?
Yes, that's all trash.
May I have them?
Sure.
I'm gonna make my own wallpaper. My plan is to cover the wall with pieces of wallpaper arranged so none of the wall shows through. If I cut all the pieces into the same size square, then all the pieces should fit together without any gaps or overlaps, because all the sides of a square are the same length. But I'd rather use a more interesting shape. How about if I turn the square into one of my favorite things about New York City? The skyline. This could be a problem. I don't want the wall to show. I need to move the part I just cut off to the bottom of the square. If I use this as a pattern and trace it, I can create new pieces that are exactly the same shape that fit together without any gaps or overlaps. Wow, that is a really cool tessellation.